So now we are going to discuss reference data type. So what is reference data type? The reference types do not contain the actual data stored in a variable, but they contain a reference to the variable. So what does it mean? So in previous slide, we have discussed when we declare any value data type, memory would be allocated on stack. But in case of reference data type, actual memory would be allocated on the heap memory. So the memory has two parts. One is stack memory and another one is heap memory. So whenever we declare any reference variable, memory would be allocated to that particular reference variable in stack, but actual object would be created on the heap. So suppose this is the memory address of it. So now X holds the value of that particular object. So it is the address of that particular object from the heap. So X do not contain the exact value of that particular variable. It's pointing to the memory address of the heap where the object is created by the runtime environment. So reference variable do not contain the actual data, but contains a reference to that particular variable. In other words, when you create a variable of reference type, you are essentially creating a pointer to the data rather than storing data directly in the variable. So as we discuss here, 101 is the memory address and not the actual data of that particular variable. So the actual data would be stored over here. And the memory address is 101. So X is a pointer variable which is pointing to the memory location where the exact memory would be allocated by the runtime environment in case of reference data types. In common examples of reference types includes class objects. So when you create an instance of a class, you are working with a reference type. The variable you declare to hold the object stores a reference to the actual object in the memory. So the reference variables would be stored on the stack and actual object would be created on the heap. So the reference variable contains the address of that particular variable on the heap memory. Arrays in many programming languages like C# or Java are reference type. Create an array variable, it holds a reference to the memory location where the array's elements are stored. So array elements would be stored on the heap only. So this is the array. This is the reference variable which pointing to the memory location where the exact array would be created into the heap memory. So similarly, class interfaces are also a reference data types. Variables that represents interface types are also reference types. They point to objects that implement the interface. Delegates and events, so these are nothing but the function pointers. They point to the methods or functions that can be executed. So that are also of reference data type. So let's understand with the help of this program. So here in static void main method, before static void main method, we have declared one class which is of type user. So user is a user defined class which contains age attribute which is of type integer data type. So in class program, here we have created the object of that user class with the help of new keyword. So user one is the reference variable which would be stored on the stack. So the user one variable would be stored on the stack memory and actual object of user class would be created on the heap memory. Suppose this is 108 address. So 108 would be assigned to user one, that is reference variable, and which is pointing to the memory location from the heap. So user one contain age as it is value data type. So value would be allocated here only. Age is equal to 10. So now we are creating another object of same class, that is user2. So we have declared one user2 reference variable, and we are assigning the object user1 to it. So in memory, in stack, both variables would be memory would be allocated like user1 and user2. So both are reference variables, and actual memory would be allocated into the heap memory. So this is the user object which contains age variable. The initial value was 10. Now here we are just printing the user1 age and user2 age with the help of console.writeLine. So console.writeLine is used to print the data onto the console command prompt. So now here we are modifying the value of age is equal to 20. So here user1 and user2 are the separate variable names, but both are pointing to the same memory location. So this is 101. So user2 is also pointing to the 101 and user1 is also pointing to 101. So the same copy is shared between both variables. So even if you are modifying the age variable from user2 object, user1 object is also get modified. So after printing user1.age and user2.age, value would be same for both objects, that is nothing but the 20. So now we are going to discuss reference variables in which same object would be shared between two reference variables as per our discussion in previous slides. So here we have declared one class user which contain age attribute having data type integer. So initial value of age is 10. So in static void main, we have created one object user1. So user1 is the reference variable, and with the help of new keyword, we are creating the object of user class. So here we have declared another variable user2 and assigning the user1 variable to user2. Now user1 and user2 pointing to the same object. So let's understand this. So now here we have printed both user1 age and user2 age. So as both are pointing to the same memory location, so the value of the age is 10. So this line will print user1 age is 10 as well as user2 age is 10 only. But after that, we are modifying the age attribute and assigning the value 20 to it. So as user1 and user2 pointing to the same memory location and same object, so the copy would be shared between both variables user1 and user2. So as soon as we modify the value of age of user2, user1 variable also get modified. So here, whenever we print the user1.h and user2.h, both having the same value, that is nothing but the 20. So let's run the application. So let's debug the application now. So in first line, we have created the object user1. In second line, user2 is equal to user1. And now we are printing the user1.age and user.toAge on console. So the value of user1.age is equal to 10 and user2.age is equal to 10. So both having the same value because both are pointing to the same memory location and sharing the copy of that particular object which was created by the user1. After that, here we are modifying the value of user2. So now user2 age is equal to 20, but the copy would be shared between both variables. So both variables get modified. So after printing the value of user1.age and user2.age here, both contain same value 20 and 20. So it proves that in case of reference type variables, so the same object would be shared between both variables or objects. 20. So let's understand the difference between value type and reference type memory allocation. So this is our program. We have declared one method, method one. So in first step, we are declaring the integer data type variable. So memory would be allocated on stack directly and value would be assigned here only immediately. And it is not pointing to any memory location or from heap. So the next one is int b is equal to 20. So it is also a value data type. So it would be stored on stack only. Now we are creating the object of employee class. So as we discussed, class is a reference data type. So EMP would be a reference variable and contains memory address of the object where the memory would be allocated by runtime environment on heap. So the employee object would be created on heap memory and that memory address would be stored into the employee variable. So all the value data type would be stored on stack and the value directly assigned over there. But in case of reference type variables, reference variables would be stored on the stack, which contains the memory address from the heap where the exact or original object is created on